Well, happy Mother's Day, everybody. And we took a look at Genesis, the first chapter, and parts of the second chapter. Some of the inconsistencies in the Bible when we're talking about the creation of the world. And I thought it'd be interesting to just kind of continue on in Genesis because there's just so much in that book that forms the basis of biblical doctrine. I was recently watching the Atheist Experience with Matt Dillahunty, who hosts that show or is a frequent host of that show. And he was co-hosting with I can't think of his name now, Dave. His first name is Dave. He was a minister and a minister who became an atheist. He also has ALS. And he has an incredible knowledge of the Bible, and he understands from a theological and a doctrinal point of view the inconsistencies of the Bible and the problems that many evangelicals have with denouncing or showing that Genesis is problematic, from a realistic point of view, that the science of Genesis doesn't hold up. And because the science of Genesis doesn't hold up, the doctrines of many of the fundamentalist religions are severely impacted. Catholicism is not, interestingly enough, is not as impacted. I mean, Catholics recently accepted, in relative terms, recently accepted evolution as valid. I believe it was Pope John Paul who finally conceded on that point, that science is correct. They even have a Vatican astronomer. They adhere to the latest understanding of science, and they have their own astronomer who is a priest. And if you ever saw Religulous, he was interviewed by Bill Maher, who produced that film and starred in that film. I have to say, Religulous was one of the movies that really helped substantiate my atheism. I had questions for a long time, but it certainly helped me to understand the satire and the comic side of the whole thing by taking it realistically, by believing it as real. And it and it just can't make sense. When you're born and you're raised and you're exposed to this, you don't see how utterly ridiculous the teachings are. But when you really can allow yourself to step back from it, it's almost embarrassing to think, did I actually believe that at one point? And you really can't be too hard on yourself, because people will believe in some pretty outrageous things if it's I mean, we're such easy prey. We're such easy prey because so many of us can fall victim to con men. And that's basically what religion is. It's a con game. It's something that has been pushed on us from the time we were born. And because it was impressed on us so strongly from the time we were impressionable, it doesn't sound ridiculous because it comes from a source from whom you rely on everything. You rely on your parents for your sustenance, your clothing, your warmth, your protection. And so you believe them. You believe the system, the many others who attend church on Sunday who also have the same convictions and beliefs. And so it can seem real, and it can be and is reinforced in our lives over and over and over again. So it becomes real to us. But then if we can allow ourselves to step back and look at the incongruities of the Bible with what we know to be fact, then we can see how childish really it is. It's because when I say childish, I mean it in the sense of naivety. Because human beings were naive at the time the Bible was written. They didn't understand science. They didn't understand how the solar systems came to be. They didn't know what fusion was. I mean, my God, we didn't know what fusion was. We didn't know how a star worked until we understood the atom. And we didn't understand the atom until a model of the atom first came to be. And that's a little over 100 years ago, really. So it's relatively recent. My grandfather was born at a time before they understood what the atom was. Interestingly enough, for those of you who are Jehovah's Witnesses, if you go to the Watchtower headquarters, they have a little museum there, and at this museum they have certain artifacts of Charles Taze Russell, top hat and his cape and his cane, and golden-handled cane, no less. Understand he was quite the dapper dresser, but somehow some of the Bible students managed to come off with some of Russell's possessions. One was a little folding portable cup, silver cup, that telescoped in and out. And that was his, and he used to bring it wherever he went to drink water with. They didn't have dispensing, Coke machines back in 1900 or in the 1890s, and they may have had fountains, and you brought a cup with you, and he had a little pocket cup. Another was a top hat. I'm sure he owned many top hats, but it was one of those things you see like a Monopoly hat. And he also, in this collection that they had at the Dawn, were the Catholic encyclopedias that he used for reference for his science. And me being a physics student at the time my wife and I were at the dawn, I was interested in what kind of science they had back then, and it wasn't a complete set of encyclopedias, but it was the Catholic Encyclopedia, and Catholic in the sense of universal, and that's what the word Catholic means. That's where the word derives. It means universal, universal church, the Catholic Church, and the this particular volume was from the 1890s. This particular encyclopedia. And I looked up electron, and they didn't have it. They didn't know what an electron was. So in the 1890s, they did not have this idea. There was an early model of the atom that was first proposed. They call it the plum pudding model, where you had this mass of positive charge, and you had the electrons like little raisins within the pudding, and they were embedded in the pudding, and they exactly electrically counterbalance the positive charge, and so the whole thing was electrically neutral. Well, then they went to Niels Bohr's model, which is what you always see. It's the nucleus with the looks like an orbiting solar system, with the different orbits of the electrons going around the nucleus, and the nucleus made up of protons and neutrons. And the simplest atom is the hydrogen atom with one proton and one electron, and you can have three flavors of hydrogen. One with a proton and a neutron. That's your most basic hydrogen atom. And then you have what they call deuterium, which is one proton and two neutrons and one electron. And then tritium. And tritium and deuterium are radioactive. They break down over time because the bond, the what they call the strong force, isn't strong enough to keep the atom together, and there's a period of time. I think the half-life of tritium is a little over, well, maybe closer to 5,000 years, close to it's under 5,000 years, but it's close. I'm just going off the top of my head. I mean, I could go right here, half-life of tritium. In fact, you've seen tritium. If any of you remember exit signs that don't need electricity, they glow in the dark. That is a tritium exit sign, and back in the 50s and 60s, they were very popular. Tritium, tritium radioactive has a half-life of 12 and a half years. Okay, but I thought maybe it's C14 that I'm thinking of. Tritium has a half-life of 12 and a half years. Carbon 14 half-life. That's what it is. I'm thinking of carbon 14. Yeah, 5,700 years. Yeah, the carbon 14 has a half-life of... And a half-life basically is... if you start out with pure carbon 14, the radioactive decay is at a steady rate where you have half the amount in 5,700 years, and then half that amount again, and another 5,007. So you have a quarter of the amount in almost 12,000 years, And then in 18,000 years, you have an eighth of the original amount, and so on. And it makes this curve that you see. It's what they call a half-life curve. And if you plot it on a XY coordinate, your half-life would go down in this direction as time proceeds in that direction. The amount goes down, and it goes down exponentially, and they call that a first rate law. And so we really kind of deviated a bit, but anyway, they didn't have this. They didn't have a clear understanding of even the atom in Russell's day, so they didn't understand how the solar system could even come to be, because the sun is a nuclear furnace, and it's not burning like you would think. Chemical oxidation occurs today when you take wood and you put it on the fireplace or your gas range, and you take a match and light your gas range. That is a chemical process. That's chemical oxidation, and that is a when you're creating a chemical reaction between the oxygen and the gas, and you have a certain amount of energy that causes this reaction to take place, and then it gives off even more energy, so it becomes spontaneous reaction until all of the fuel sources run out. So once your gas runs out, then the flame stops. But as long as the gas is there in sufficient quantity, the oxidation will continue. As long as you got enough oxygen and enough gas, the chemical reaction will continue. That's not what's happening on the sun. The sun, on the other hand, is just hydrogen. There's no oxygen on it at least in the initial stages of a star. It's nothing but hydrogen, and this hydrogen is drawn together. A hydrogen atom, again, is just a proton, neutron, and an electron, depending on the type of hydrogen. Again, there are 3 types of hydrogen. And there's so much of this hydrogen that was formed at the beginning of the universe, the Big Bang, they call it. There was so much hydrogen that was created that it pulled together from gravitational attraction large, unimaginable amounts of this gas was pulled together and created a tremendous gravitational pull towards the center and compressed this gas to the point where you ionized it, which means you strip the electrons away from the protons. And so you have at the center of the star these free moving particles of electrons and protons, and these protons hit with enough energy that they fuse together to make helium. And when they fuse together, they give off energy. Some of the mass is converted to energy. So you have this expulsion of energy. So while you have gravitational attraction that's pulling the gas together and causing it to fuse into helium, you have this outward push of pressure. And so there's a balance that occurs. The gas just doesn't keep pulling together, but it pulls together to the point where it begins fusing, And the fusion then creates an outward pressure that balances out, and you end up with a star that emits high amounts of energy, and you have this fine balance, a gravitational pull into the center of the star and outward push of energy from the release of energy from the fusion that's going on. And so the star remains stable. And once that happens, the star ignites its fusion energy. And none of this was understood because they didn't understand what an atom was until the 20th century. So our understanding of how a star works is relatively recent, especially in human history. So nobody really understood this until this is modern science. And we know this occurs because everything that we know about a star and fusion and what fusion predicts theoretically is what we find in science and is what's occurring. We look at the spectrum. We expect that if these atoms are fusing from hydrogen into helium and helium into lithium and so on, that after a while you begin to accumulate these different elements up to iron. A star will create iron. A star is a matter-making engine. That's really what a star does. It starts with the basic fuel of hydrogen, and the fusion process starts making new elements. And these new elements are there as part of the mass. When they fuse, is given off as light energy, photons. And a lot of that light is light we can't see, gamma radiation. A lot of the light is in the UV spectrum. We can't see ultraviolet light. We can't see infrared light. We have what we call the visible band spectrum. That's from the blue to the red. And you got blue and violet and green and yellow, and then orange, and then red. And then you have ultraviolet, and they're all different wavelengths. It's all different energies of light, photons. And so that is being emitted by the sun, as well as particulate matter, protons. That's what we call cosmic radiation. But our understanding of the star being a fusion engine is what everything that we would expect from fusion we see. We see these different elements as part of the sun because the sun's making these elements. And as the sun ages, these elements become increasingly, they overwhelm the amount of hydrogen that can fuse together. And then the balance of pressure, outward pressure versus the inward pull, begins to change, and the star begins to become what they call a red giant. The pressure becomes larger and larger because there's more energy as larger molecules, larger elements fuse, and then the fusion stops, and gravity pulls everything back together again in a shock wave bounce. After everything hits back, there's a reactive bounce, and that's a shock wave that shoots the rest of the hydrogen off, and the rest of the core elements remain at the center of the star, and it becomes a hot white dwarf. And that's the fate of our sun, our yellow star. For, I think, 100 million years, it'll be a white dwarf. Again, I have to refresh myself on some of this. I'm going by memory. But yeah, we didn't know what a star was until the 20th century, and now we understand that, and we've made. In fact, this morning I watched a show about our what we call chrome dome. Back in the 1960s and 50s, in the Cold War, we had some 3,000 aircraft, B-52 bombers that were part of the Strategic Air Command, and they all carried fusion bombs. The same principle as a star works, and so even in Russell's day, they didn't understand as much as we do today about how a star even works. So they had no idea of how old the universe could be. I mean, these stars have enough fuel to burn for billions and billions of years. And our star is about 5 billion years old. The universe is about 15 billion years old. And the way we know that is through the redshift of the expansion of the universe. We can see the rate of expansion, and we work backwards, like running a film backwards. If you broke an egg, you can run a film of the egg breaking, and then you can run the film backwards and watch the egg magically put itself back together again. Doesn't really happen that way. Entropy prevents things from spontaneously reassembling themselves like that, but we can, so to speak, run the clock back, and understanding the rate at which the universe expands, we can estimate how old the universe is. And that's how some of these estimates of 15 billion years first came to be. But now we realize that there's another factor involved. They call it dark energy, and dark energy has made us realize that the universe is actually accelerating. And so it's not a constant rate of expansion, it's actually increasing. The rate of expansion is increasing over time. And so the universe is actually a little younger than initial estimates, when they thought the rate of expansion was constant. So right now, the estimates of the universe, the age of the universe, are 13 billion years. And the problem with evangelicals and Bible students and Jehovah's Witnesses and all those that take the Bible literally is that it ruins the concept of the ransom. Basically, the idea that the human race all descended from two people, Adam and Eve, and that we all inherited sin, and that Jesus was sent as a substitutionary ransom to pay for the sin of the first pair and release the human race from the sin that they inherited from the first pair. But there are so many problems with that. Even the equity of the idea that the children should pay a penalty for the sin of the parents. I mean, how about the children of criminals? We don't hold children responsible for a crime that the child's parent may have committed, even if the child wasn't born at the time the parent committed the crime, especially then. I mean, it's just something that we innately understand, that there's no equity there, there's no justice there in holding people responsible for their parents' misdeeds. So, that's an aspect of the Bible that just doesn't really make a lot of sense from a justice point of view. And so there's a problem. And we didn't really touch on that so much as the innocence aspect of it, that how could they be held responsible for disobedience if they didn't know what disobedience meant. And so, but then you have this whole other aspect that the human race is held captive to sin, and the terrible consequences of sin, dying and sickness, and all of the other things that go along with this curse that came upon the human race, at least according to the Bible. How is that fair? How is that equitable? And how does one man offering to take the place of somebody else's misdeed? Now, if we did this in the criminal courts, it wouldn't work. I mean, what if somebody? I mean, you couldn't expect that somebody would take the place of Charles Manson, right? I mean, and say, look, I'll volunteer to go to jail for his crime. I mean, it just doesn't make sense. And no judge in the world would ever accept a deal like that. Even no matter how willing somebody might be to step in and pay for the crime. So it comes down to God having to accept an arrangement that is just not really equitable to begin with. And so why even go through it? Why hold the children of Adam and Eve accountable in some sense to the sins of Adam and Eve? It doesn't make sense. Oh, because they were imperfect at the time the children were born, then the children were born into imperfect. No, that doesn't really hold. That doesn't make sense, from an equitable point of view. We wouldn't do it. And if we are made in the image of God, why then would God do it? So there are a lot of things that just, looking at the Bible itself just don't make a lot of sense. But one thing I got looking at, and I thought it was kind of interesting, we looked at, we already kind of played out that aspect of Adam and Eve and the original sin. This is the one of the problems that evangelicals and everybody that believes in the Adam and Eve story, has with science, because science it just doesn't make that whole idea of original sin and redemption and salvation make any sense at all. It disrupts that entire thing, and that's why so many fight it so strongly, because it's unnerving to see the foundation of your beliefs from the time you were born shaken. And so that's why it's so difficult for anybody to understand and to accept atheism, because it loses. You've lost this whole mythology of hope. That if there's this thing holds out a hope for people to get some other shot, a better deal at things. And don't we all want a better deal? I mean, we all have our troubles. They're all of us. No one is better off than the next. We all have our troubles, and we would all like to get a second shot at having a life that's completely and utterly trouble-free. But then, in a sense, that's one of the things about life. If it was all handed to us, we wouldn't really appreciate it so much. Being given a paradise and not having an incentive to live and to pursue things and to, I don't know, I think the struggle of life in a way gives us a sense of meaning, certainly more so than hoping for a better future and putting all my eggs in this basket by saying, if I just do these things and believe these things by faith, even though they don't make sense, I'll have a better life. I find it much more interesting to face the challenges of life and to live this life to its fullest than to wait for something better. We can make it better. We can make it more interesting. We can learn about the fascinating things about this universe if we open up our minds to do so. And it's a freeing and liberating feeling to do that. So, well, with some of that said, for whatever reason, we'll start looking at some of the second chapter of Genesis. And it says here, and remember, there were two creation stories. When we look at Genesis, there really were two creation stories. The first chapter of Genesis, and then the second chapter kind of picks up a whole different line of the creative narrative, the creation narrative. Thus the heavens and the earth were finished, and all the host of them. And on the seventh day, God ended his work which he had made, and he rested on the seventh day, which he made from all his work. And God blessed the seventh day, and it sanctified it, and because he had rested in it, he had rested from all his work which God created and made. Again, those words are most likely Asa and Bara, which have been used throughout the Genesis context up to this point, throughout Genesis 1 and 2, for the word made and to make and to create. And it says, these are the generations of the heavens and of the earth, and when they were created, in the day that the Lord God made the heavens and the earth. Everything sort of, it was I forget, there was something in literature I remember taking in college, and this style of writing when when they kind of repeat things. There's a specific name for that, and I can't recall it right now. But it's a form of emphasis, and it's an ancient style that was adopted to give more, I guess, make it sound more real. And every plant of the field before it was in the earth, and every herb of the field before it grew. For the Lord had not caused it to rain on the earth, and there was not a man to till the ground. But there came up a mist from the earth and watered the whole face of the ground. And then the Lord, in the 7th verse, it says, the Lord formed the man out of the dust of the ground and breathed into his nostrils the breath of life, and the man became a living soul. And he planted a garden eastward in Eden, and there he put the man whom he formed. And out of the ground made God to grow every tree that is pleasant in sight and good for food, the tree of life also in the midst of the garden, and the tree of knowledge of good and evil, which we spent a lot of time talking about last time. And then it talks about the rivers. It says a river went out of Eden, and it broke into 4 heads. So this is, now everybody tries to place Eden in a particular location. But there's no location really that fits this narrative that we can identify with any positivity at all. I mean, the fact that the Mormons think that Eden was somewhere in Missouri. I wouldn't think. Maybe it was the Ozarks. I don't know. But there isn't any single place here where we can have any kind of a real geographic reference to identify, because this doesn't make sense in the context of the Middle East, in which most people believe this was describing, because it talks about the Euphrates. It mentions 4 rivers here. You had this river that came out of the garden and broke into 4. Sounds like 4 tributaries. And usually rivers go the other way. They start from multiple sources, and then they begin to connect into and aggregate into larger and larger water bodies, and then flow out into the river or into the ocean. And so this doesn't make a whole lot of sense, that you had a river that broke into 4 tributaries. And here this is sort of, these rivers are being given as a means to delineate where Eden was, and it really is vague. It's very vague. It's not something that's well defined. It says, and a river went out of Eden, and then from thence it parted and came into 4 heads. And the first was the Pison, which is compassed the whole land of Havilah, which I guess is Arabia. When I looked it up, it was Arabia, Mesopotamia, northeastern Mesopotamia. But the first reference I got was Arabia, where there is gold. And the gold of that land is good. I'm not quite sure why they would say the gold of the land is good. I mean, gold is a precious metal, and precious metals have always been held in high value. So I don't know why that gold would be particularly good. And then there's bdellium and onyx stones. So I guess these are precious stones. I'm not familiar with I'm not really familiar with this particular gem. Onyx is silicon dioxide, quartz like stone material. Some quartz is semi-precious, I guess, but it's not a particularly valuable stone. And it says the second river is Gihon, and that is the same as that compassed the whole land of Ethiopia. Well, you see, now here's the problem. I think this word Ethiopia, Cush, I think that it is the land of Cush, which is often in the Bible more often references Ethiopia. And the Coptic Christians in North Africa believe the Nile is being referenced here. And see, this is part of the problem because the Nile is not a tributary or a branch of any of these other rivers that have been identified, especially the Euphrates. So again, this whole context here doesn't really make any sense. People think that they understand that that Eden was someplace in Mesopotamia, but it really isn't anywhere that you can geographically locate anywhere on the earth in particular. And then you got the river, third river, Hiddekel. I guess I don't know if I'm pronouncing it right, which goeth east of Assyria. Again, that's more in the Middle East, and I guess sort of in the western portion of the Middle East. And the fourth is the Euphrates. And the Euphrates was the river that went through Babylonia and through Mesopotamia. You had the Tigris and the Euphrates rivers. And you had this description that you really can't place. But this is where God planted a garden eastward in this Eden, which is supposedly geographically located using these rivers. So we can't really find these places in any kind of reality. One thing I wanted to make note of, and it goes back to here where it says, and every plant of the field before it was in the earth, and every herb of the field before it grew, for the Lord had not caused it to rain upon the earth, and there was not a man to till the ground, but a mist went up from the earth and watered the whole face of the ground. Now that's something that really is quite puzzling. And the thing that's puzzling about it is that there is really, how does that work? You see, the Earth operates on what we call the hydrologic cycle. And the hydrologic cycle is a very complex process that transpires on the Earth because of the oceans. Now, this planet is, the face of this planet is about 71% of the surface of the Earth is covered with water. That's what makes the Earth one of the more unusual places in our solar system. Although we're finding more and more water all the time in the solar system, for the inner planets, we are the only of the three inner planets that, or four inner planets that has an ocean. Now, Mars may have had an ocean at one time, but lost it. It wasn't massive enough a planet in order to maintain its ocean. There's evidence that there was large quantities of water, and there's evidence of erosion on Mars. But Earth is the only planet in our solar system that has a liquid ocean that has a substantial amount of water. Now, the ocean, again, is 71% of the surface of the Earth, and it averages 2.3 miles in depth all over the Earth. That's over 12,000 feet, and that's a lot of water. When you stop and you think about the volume of water that's within the oceans, it's a tremendous quantity of water. And one of the mysteries of our planet and Earth science is, how did all of this water get here? And there are several theories. One of the theories is that there was a planet that disrupted in the early solar system. There was a planet that disrupted the Oort cloud, which is made of comets. Comets are largely made of water, and that we had a particularly heavy bombardment of comets that may have contributed to the oceans. There are other theories people are exploring now that the water may have actually been here all along. Actually, water is basically one oxygen atom and two hydrogen atoms, and so all of the constituents that would have gone into the making of our solar system, many of the elements would have already been here. Certainly the hydrogen. I mean, the sun was the aggregation of most of the hydrogen that made our solar system up. Jupiter and Saturn are also largely made of hydrogen gas, and so there was a lot of hydrogen in the early solar system. So there may have been a natural quantity of water that aggregated with the asteroids. In fact, they do find water in asteroids, and so there may be. In fact, we find water on the moon, within the under the surface of the moon. There's water trapped within the rocks of the moon. But how the water got here in the early solar system, there was enough mass on our planet to maintain the water on the surface. It didn't just evaporate and move off into space as it did with Mars. Earth is quite a bit larger than Mars, and so, plus we have a magnetic field that protects the Earth from being bombarded from cosmic radiation, or the ions that are emitted from the sun that would strip not only the atmosphere away, but also our oceans. So the oceans have been preserved. And because of this vast quantity of water, I ripped off this picture here of what we call the hydrologic cycle. They call it here the water cycle to keep it a little simpler, but it's the hydrologic cycle. And this is a nice image from the USGS that gives you a sort of simplistic idea of how water interacts on the planet. Now, when we understand the dynamics, what we call the geophysics of the Earth is the Earth is made of rock and iron. So the core of the Earth is nickel iron. The central core of it is molten, and then we have the mantle, which is an outer layer, which is largely rock, silicon dioxide, but a denser form than the granite, which forms the continents. And the continents are the lightest rock on the planet, and so it floats on the surface of the mantle. And as the mantle, which is a plastic or semi-liquid substance, it creates these thermal cells, like a pot of boiling water, and those thermal cells cause the floating chips of granite we call continents to move around. We call it the continental drift theory. And so you have these land masses that are moving along on the crust of the Earth. And as land masses collide with one another, they make mountain ranges. And so water evaporates from the ocean into the atmosphere, and as you rise in elevation in the atmosphere, the air becomes less dense, and it cools off. It's what you call adiabatic cooling. And so the mountains force warmer air that's full of water up into the atmosphere, and as the water containing atmosphere or air moves over the land and pushed up by the mountains, it's cooled off. And you can see that these mountains over here to the left cause the cooling of the air to condense the water out into these clouds, and that creates precipitation. And you can see this precipitation here on the leeward side of the mountains, or windward side of the mountains. And that precipitation begins to fall, and it can come down in as snow or rain, and it begins to infiltrate the ground as well as run off on the surface of the ground. And it makes rivulets. The rivulets aggregate to make streams. The streams aggregate into making rivers. And so opposite to what is occurring in Genesis, rivers are actually an aggregation of smaller streams that all come together, and streams will they form as tributaries to larger rivers, and rivers will join together to make even larger rivers, like the Missouri River joins into the Mississippi. So the Mississippi River is an aggregation of the Missouri, the Ohio River, the Arkansas River, and there are many rivers that flow into the Mississippi, and ultimately into the Gulf of Mexico, which is part of the Atlantic Ocean. And so this is how the hydrologic cycle works. And when some of the water aggregates into depressions, you have impoundments, and that forms freshwater lakes, and some of that water infiltrates into the ground, trickles through the ground. Now the ground isn't impermeable. You have soil, and the water makes its way through the soil down into the rock, and the rock is fractured and cracks, and it fills into the cracks, and these are what we call aquifers. And you can see that in this image here, that there's water in the rock itself, and we call that groundwater. In fact, 40% of the water that we drink in the United States comes from groundwater. Many people think most of our water comes from reservoirs and such, but most, especially in rural areas, people drill wells for their drinking water. And so groundwater is a huge reservoir of water, fresh water for the earth. And much of the precipitation also becomes locked up into glaciers. We have a large aggregation of fresh water in the north, up on the island of Greenland. A tremendous amount of fresh water has accumulated up there in the forms of glaciers. All of Antarctica is covered with a thick layer of ice that has accumulated over a long, long period of time. This just doesn't happen overnight. You can't start a hydrologic cycle in one day. You can see here that this is a very complex cycle, and it requires the end. Really, the engine for all of this is the sun, and you can see all of the components here that go into the hydrologic cycle. It's not a very simplistic thing. It's not just a mist rising from the ground that waters the land. It's a very complicated situation. And as long as there was land, as long as there were mountains, and as long as there were oceans, the hydrologic cycle would work in the way that you see in this image. There would be no place on the planet that would fit the description that is given in the Bible. Now, there are certain climates, certain places where you have more of a cold, what they call maritime climate, and it's foggier. But the fog alone is not accountable for watering the whole, providing all of the water for that particular place. It's going to rain, and it has always rained. As long as there has been an ocean on the planet Earth, there has been rain. And there's evidence that the water on our planet has been here for a long time, for about as the Earth became covered with an ocean very early on in its life. It's not we have aquifers that we can date with radiological methods that are very ancient. I mean, some aquifers have water that's millions of years old, and the way we can tell is by doing isotopic measurements on how much tritium or how much deuterium is in the water, present in the water, and other constituents. Not all water is the same. Some water has different constituents in it, depending on the minerals that it comes into contact with in the ground. And so it's not as simple a situation as the Bible might make it sound or seem. And so it doesn't seem to jive this idea, this simplistic idea that there was no rain. In fact, I remember being brought up to thinking that, believing that it didn't rain on the earth until the flood, and that the flood was the first time it rained. And that was the idea that was prevalent among most Christians. And I believe even the fundamentalists believe that today, that there was no hydrologic cycle as we understand it today until the Great Flood. And there's just no evidence that this would have ever been the case. As long as there were oceans and there were mountains and continents, and we know for as long as the Earth existed that there have been continents and oceans for pretty much the length of the Earth's existence, except for the very, very early years when the Earth was very hot. But once the Earth cooled down, the Earth has been in this condition for billions of years, 3.5, 4 billion years. And this process has been going on for that entire period. And so, this is something that we should remember when we look at the Bible, that it's not as simple as what the Bible makes it out to be. So we have to take a realistic look at the scriptures and say, does it make sense? Does it make sense? And it really doesn't, because again, it comes down to the naivety of simple humans, primitive humans that didn't have an understanding of science and an understanding of this whole process. So we have to take a look at the reality of things, the reality of our world. How does our world work? And how does what makes sense? We have evidence that the climate has changed many times over the millennia, over the millions of years, over the billions of years that this planet has been in existence. There's strong evidence that there were periods at which this whole planet was nothing but what they call iceberg Earth. And the whole planet was frozen. The oceans were frozen. And then there were other periods when all of the continents were together in one mass. And in sort of a Pangea situation where they were all joined together, and that would have created a different kind of climate for the Earth, because the circulation of heat in the ocean currents and the way precipitation would have occurred. How the hydrologic cycle would have occurred under a scenario where the entire land mass was all together, and the center of that would have been largely a desert, and the perimeter of the continent would have been more or less where the precipitation resided, especially where mountain ranges would have existed. And the climate continually changes as the different continents are moving into different directions. The flow of oceans. In fact, one of the things we realize that the Earth has been going through cycles of ice ages, I forget what the periodicity is. I believe it's every 100,000 years or something like that. But the periodicity, there was a time when the North America wasn't connected to South America with I can never say the word isthmus of Panama. The Central American countries there were not present, and it was an open connection between the Pacific and the Atlantic, and that flow through allowed for a more generally warm climate to exist. And when that closed off, it cut off that circulation, and there was a change in the heat transfer to the north, and it began a cyclic form of ice ages, repetitive ice ages. And I think there have been, over the last several million years, 4 or 5 different ice ages that have occurred. And we're still technically in an ice age until Greenland and Antarctica melt completely. But they are receding. The climate is warming. We are contributing to that warmth by emitting carbon into the atmosphere, where we're exacerbating a trend, accelerating a trend that was already in process. But that's a different subject. But when you look at the Bible, again, it just doesn't make sense with what we know, especially during the period of time in which humans existed on the earth. The hydrologic cycle has clearly been in place for all that period of time. And so there's no way that this description that's given in Genesis regarding the Garden of Eden and the way that water distributed itself on the planet. I mean, you can't form major rivers by some misty, foggy condensation. You need sizable amounts of precipitation that occur. I mean, that's how the rivers all form on our continents through this hydrologic cycle that we just got an image of. So anyway, I think it's worth taking a look. I think the hydrologic cycle is a fascinating thing, and it's worth taking a look at. You can find everything you want to know about the hydrologic cycle on the USGS, also NOAA, the National Atmospheric and Oceanographic agency, that governmental agency that studies atmospheric and climatological phenomena. You have all of this wealth of data and information at your hand. It's our tax dollars pay for it, and it's worthwhile science to get to understand. So anyway, I just thought that we'd take a look at this a little bit because it never made sense to me. It was, again, one of those types of stories that you get when you're a child and you're indoctrinated with stories from the Bible and its simplistic way of looking at everything, everything. It becomes so evident that there's that it just is not the way things really are, and the more you realize how the earth and nature really works, the further the Bible seems to be from any kind of a reality that we can put our trust in. How can we put our trust in something like that? So anyway, I realize that we kind of went on a little bit about this, but I think it's worth it, and I think it is helpful to understand that there is an understanding of how water works on our planet. It's not a simple thing. It's a very involved process. So anyway, I think one thing that we want to take a look at further in Genesis, there are so many things. There's the length of life, no evidence of anybody ever living 900 years. There's the Great Flood itself. And I think that would be kind of fun to take a look at how much water, do some calculations, and take a look at how much water there would have to be to cause the flood to cover all the mountains of the earth. So I know that these people have done these calculations. It's like the calculation of Santa Claus and how fast Santa Claus has to go down a billion Christian chimneys in a single night. He'd have to violate every law of nature we know to do so. So, but yeah, there's so many things about the Noah's flood that it'll be interesting to take a look at. So anyway, maybe we'll look at that next. I wish everybody well, and again, happy Mother's Day.